Hello, welcome to RCC's Math Tape 092, Solving Systems of Linear Equations by the Substitution Method. As we go through this material, I will expect you to know what a system of linear equations is and what it means to solve them by graphing. If you have not studied what's on tape 091, you need to do so before you study this tape. As we do the material, please be sure to mark on your paper any place that you don't understand as you take notes. And any problems that give you trouble that you need help with, you should also mark so that you can ask for help from the lab when you go and get help from an instructor or a tutor there. Now let's begin. Our objective on this tape is to solve a 2x2 system of linear equations by the substitution method. On tape 091, you learned to solve a system of linear equations by graphing. Graphing works wonderfully when the solution is a pair of integers, an ordered pair of integers, and when the integers are located easily on the graph you have chosen. However, solutions to systems of equations may be fractions, or they may be ordered pairs of numbers that are outside the range of the graph that you have chosen to work with. And so we must have some methods from algebra to solve systems of equations. This tape covers one of those methods, the substitution method. I'm going to begin with a procedure. This procedure is rather lengthy. Be sure to copy it down exactly right because you must have all the steps present to make it work. After we go through this procedure, we'll look at examples, and that will clarify many of the questions that you probably will have if you've never used this method before. The first step in our procedure, solve one equation for one of the variables. Solve one equation for one of the variables. That is, to get one letter by itself on one side of the equation. Step 2, substitute the expression into the other equation for that variable. Substitute the expression into the other equation for that variable. When you solve an equation for one of the variables, you will get an expression. This is the expression that you substitute. And this step is the step that gives this method its name, the substitution method. Substitute the expression that you got in step 1 into the other equation for that variable. You must use the other equation because you're looking for a solution of two equations. You've used one equation to get one of the variables alone. Now you use the other equation to substitute into. Step 3, solve the resulting equation for its variable. Solve the resulting equation for its variable. By this time, you should have obtained a single equation with one variable, and so we solve for that variable. Step 4, back substitute to find the value of the other variable. Back substitute to find the value of the other variable. By this we mean that we are to go back to an earlier equation, substitute the value that we just found in step 3 into an earlier form, to find the value of the other variable. Step 5, check in both equations because step 4 has completed the solution and the check must be in both equations. The equations that we use here must be the original equations. Remember that in mathematics we always check in the original problem. And so check in both original equations. Now, this is a fairly complex procedure. Notice that we first have to solve for a variable. When we solve for one of the variables, we will not get a number in most cases. We will typically get an expression. That expression is substituted into the other equation. Once you do the first two steps, you should be down to a single equation with one variable which you can solve. Then to finish the process, we must go back and find the value of the other variable by our back substitution. And finally, the check, the usual check in the original problem. Let's start with our examples using an example that has a procedure, has part of the procedure already accomplished. Example 1, x plus 2y is equal to 6. X is equal to y plus 3. Remember that step 1 is solve one of the equations for one of its variables. Notice that one of these equations already has one of the variables alone. The second equation has the letter x alone. Step 2 is to substitute the expression into the other equation for that variable. The expression that we have for x is y plus 3. Y plus 3 is going to be substituted into the other equation in place of what it stands for, which is x. So we'll substitute y plus 3 in place of x. That means that we'll have the x expression from the first equation, then copying the rest of the first equation, plus 2y is equal to 6. The x expression that we're substituting in is y plus 3. Now we have y plus 3 plus 2y is equal to 6. All we have to do is solve that equation. Notice that we have only the single variable y. It occurs twice, but it's only the single variable y. And so we combine terms and get 3y plus 3 is equal to 6. We solve the equation by sorting laundry. We'll get rid of the 3 on the left-hand side by subtracting 3 or adding its opposite. If we subtract 3 from both sides of the equation, that gives us 3y is equal to 3. Then we can divide by the coefficient of y, which is 3. Divide both sides by 3, and we get y is equal to 1. So here's the first part of our answer. Remember that in a system of equations, you're looking for an ordered pair that solves the system. And so y equals 1 is half the job done. Now we're ready to back substitute. The back substituting means that we go back to an earlier equation and fill in the 1 in place of y. All that's required is that the equation have the letter y in it and the letter x. As we back up through the problem, we notice that the letter y is used in all of the equations from where I'm pointing down, but the letter x does not show up, and so we must go back to an earlier place to find the letter x. This means that in this case, we go back to one of the original equations. We can use either of the equations, it does not matter which one, but we like to make things as easy on ourselves as we can. We're trying to get x as our answer. Notice that the second equation has x alone already. That means that that would be the smartest choice for our back substitution. So we choose x is equal to y plus 3 for our back substitution. We'll take the 1 value and fill in place of y. So we have x is equal to 1 plus 3, which of course is 4. And that gives us the x value of 4.